This video is for all you Houdini artists out there that had Legos as kids and never got to destroy them. So today we're going to be destroying Legos digitally in Houdini. I hope you liked my little demo scene here, my little intro. I love to see the slow-mo of it and the bricks flying, but I'm going to show you exactly how to do this with like any Lego set that you want to destroy in Houdini. Now, this is not a beginner tutorial, and this is assuming that you already know the basics of like the Houdini RBD workflow. But if you know that, then this tutorial should be super easy. So let's go ahead and get started. First thing that you want to do is go to this website called Mecha Bricks and find the Lego set that you want to destroy in their library. And these are like people that have made these Lego sets in 3D space, and they've created 3D files out of them, but you just want to go to the editor, and then you might need to make an account, but that's free, it's fine. And then you just want to go to File and Export. You want to export it as a .dae file. You can group by geometry, do vertex normals, and all that stuff. I would not do logo on studs unless you're doing like a very detailed close-up shot. You don't really need to do logos on studs unless you're doing close-up shots, because it's going to add like so much extra geometry to your scene that you just don't need. So go ahead and export it, and also before you do, remove any kind of like minifigures or extra pieces here. But yeah, go ahead and export it and then extract that folder. And what it's going to give you is a folder with maybe some textures in it, but definitely a .dae file, and this is all you need for this tutorial. So let's go ahead and get into it. First thing you want to do in a brand new Houdini scene is go straight up to File, and then you want to go to Import, and then Collada? I've never used that 3D software, so I don't know how to pronounce it, but you want to go to that importer, and then you want to navigate to your file, the DAE file. And I don't want to import anything except for materials and geometry. I'm going to scale it to Houdini unit length, which is still going to make it way too big for some reason. And then I want to turn off lock geometry. I'm going to hit merge, and then it's going to import our models here, and it's going to import it in probably the most ridiculous way it possibly could. So what it's going to give you is this like subnetwork in the OBJ level, and if you go inside of that, you're going to have, you know, your material network or whatever. You can hit L and see all the materials that it comes with, but I'm not going to use any of those. But what it does give you is this visual scene subnet, and if you go in here, it gives each individual Lego brick to you as its own geometry node, which is just absolutely just an insane way. I mean, there's like hundreds of nodes in here. This is not useful. And if you go into each one of these, you can see it's just a file node and a shader node to apply the material. And you can see and they're also all like absolutely massive. Like this is huge. This is what, like, this individual Lego brick is like 10 meters across or something. So it's like a huge brick. We don't want our Lego sets to be that big, and we also don't want them to be completely unusable. So we're going to go ahead and find a way past this. I'm going to kind of show you how you can set this up. So go all the way out to your like OBJ context and create a new geometry file. I'm going to go ahead and call this X-Wing, because that's the spaceship that we're working on. And then in here, we're going to create a for loop, and a for loop with feedback. And this is like, so what this for loop is going to do is import each individual piece and then merge it with all of the pieces it has already imported. And it will just iterate through this loop until all of the pieces have been imported into our one node down here. So we can go ahead and do that. And I can show you kind of how to do that. So first thing that we want to do actually is tell the for loop how many times it needs to run. So we practically just have to tell it like how many pieces in our Lego set there are. And if you know this number, great, but we really want to work procedurally. So the way that we do that is we need to tell it how many nodes there are inside of our visual scene subnet over here. And it looks like, I mean, we can go to the end and it says, oh, there's 697, but it starts at 0, so 698, right? 698 nodes. So we're going to go over here, back to our for loop, and we're going to go to the iterations. We're going to put this function in here called op-in children. And this is a function in Houdini that gives the number of nodes, number of child nodes inside of a subnet. So very, very useful for us. We just have to provide it with a path, So, you know, dot dot slash back all the way out, collidoscene, and then visual scene, and there. And now if we hit enter or X out of this, we can click on iterations, and look, it got the number 698. That's the number of nodes in there. Perfect. We have our number. So that's already set up. Perfect. Now we're going to give it a merge node, and this is how we're going to merge our imported geometry in with all of our feedback, like all the geometry we've already imported. So let's go ahead and create an object merge node, set it to into this object. And in object one, I'm going to go ahead and like navigate to that first part here. And we just want to do the file node, not the shader node. Okay. And I'm going to plug this in here. And I'm going to escape because I don't want my computer to crash. I'm actually going to set this to single pass right now just so we're not doing anything crazy. But yeah, so right now you can see we are just importing part 0. But we want to import the iteration of this for loop that we're on. So to do that, we need to go over to this repeat block and hit create meta import node. And what this is going to give us is a node that has these like detail attributes on it. And you can see these down here. It tells you what iteration we're on, the number of iterations, the value, all this kind of stuff. The only one that we're interested in is the iteration attribute. It's going to just tell us what iteration we're on inside the loop at that point in time. Which is very important. So we can go over here to this object merge node, and instead of putting 0 here, we're going to back out. We're going to put 2 backticks, and that's going to allow us to put in a function in here. And we're going to type detail, because iteration is a detail attribute. We're going to do -1. Now, you normally could do like a path to the metadata node, but we are actually going to do something else, and I'll show you how to do that in a second. But don't mind that. -1, that's just going to refer to the meta import node. And then we're going to do iteration, that's the name of the attribute. And then the index is 0, that's not important for us, but whatever. So iteration. And if we back out of this, we're going to get an error, and it's going to say because, oh, there's no reference to -1 here. Right? And that's because -1 refers to a node's spare input. So to add one, we're going to go up here to this cog and then say, add spare input. It's going to give us this box down here at the bottom. You might have to scroll to see it. We just want to select our little meta import node here. You can see now there's this like weird dotted purple line, and that pretty much just means that you can reference this meta import node in functions using -1. So that's a cool little trick there that took me a very long time to figure out, but it is very useful. Okay, so now if we let this run, and actually I'll let it run for the tutorial. All right, so you can see, okay, we have our X-Wing inside of SOPs, which is exactly what we wanted, but unfortunately we have no way to separate these pieces. All right, there's no attribute telling them apart, there's no material attribute, this sucks. So what do we want to do? We want to assign each piece a unique name before we merge them into the rest of this big piece soup that we have here. So we can go ahead and do that. I'm actually going to turn on single pass again because I don't want to have our loop run again until we need to. Let's do a name node, right? And right now this name node is just going to name whatever piece is coming into it. And we just want to name it, let's say something like piece, and then underscore, and then this exact same thing. We're going to name it piece and then the iteration that we're on, which is the same. It's going to be the same name as it's named like inside of that visual scene subnet. So just like this, and it's going to complain because we don't have a spare input. Just do the same thing here, and import, and boom. Now if we like go over here, we can see, oh, we have a name attribute. And what's this one called? It is piece 0. We are on the first iteration, and this is piece 0. So perfect. Now this should go through and merge it in, and then all of our pieces should have unique names, which is exactly what we need for our RBD workflow. So very good. Last thing that we need, last piece of information that we want per piece is a color, a brick color, because I don't want to use the materials that came with the bricks. So I'm going to put down a color node, and in here we're going to do something a little bit advanced. First thing that we need to do is do a spare input and do the meta import node just to kind of set that up. But yeah, so first thing that we're going to do, we want to reference the color on the material assigned to each piece. So what we're going to do is back out, go to our scene here, go to a piece, or actually we're going to go to the material tab. Let's go to this first material, and where it says diffuse, like this is the color of the piece, we're going to copy this parameter. We're going to go back in here to our color node, and we're going to paste relative references. Okay, but now every single piece that goes through here is just going to be colored green, and that's not good. That's not what we need. So we need this to be more procedural. So the next piece of information that we need is the name of the piece. So we're going to go back out again, go to our scene here, part 0, and we actually need the name of the material assigned to each piece. And then we already have that. That's in these shader nodes. This path is a path to the material that the piece needs. So we're going to go ahead and copy this. This is a path to these materials, and we want a path to this that then leads us to this specific parameter. So back out again. I'll show you how we're going to do this. We're going to expand this box here, and instead of like pasting here, we're going to paste relative references here. Okay. So this reference here is going to spit out a string path to the material that defines a material, right? So instead of this path defining a material right here, we want to use this, and then we would just want to like append this little parameter here at the end onto it. So how are we going to do that? We're going to take this, we're going to copy it, or cut it, I guess, and we're going to put it right here instead of this material path name. And we're going to close some backticks here for the next part. To append this last little parameter reference here at the end, we can just do a little plus sign, right? Okay. So now this is going to reference the material path, and then we're going to append the parameter here, specific parameter there on at the end. But of course we don't want to do just for part 0. We want our actual specific unique piece name. So I'm going to copy this and put it in here instead of 0. And actually the way that we're doing it in here is going to be different because this is already, this entire thing does not evaluate to a string. So the way that we do this is actually going to be a little bit different. Instead of doing backticks here, we're going to add it like that and like this. And then the text around it, we want to close out with quotation marks like it's a string. And that way we're just like kind of just adding this number in the middle of our string. And we're kind of building the string path here. And now it is still green, or one of the colors is green, but we're going to go ahead and take this entire expression. We're going to copy it and paste it in these other places. And as a matter of fact, I'm going to clear these out. But we're going to paste it in these other places. And instead of R, we're going to do G for green, and then here we're going to do blue, RGB. Okay, one thing that I forgot to do is make sure that this is a string parameter that this is outputting. So just make sure you put an S here, and that's just going to tell Houdini, okay, this is a string in here. Very annoying, but it's a little bit of debugging we have to do. But once we do that, then we actually have the red color that is assigned to this piece. And if we let this for loop run, and I'm going to go ahead and do that right now, and I'll show you kind of what the colors look like. And boom, we have an X-Wing with names and colors. Perfect. This is exactly what we wanted. We have all of our pieces inside of Houdini. We have a Lego set in here, which is awesome. But some of my colors are incorrect. So the way that you can kind of change that is if you hit S on the keyboard to go into your selection mode, and then you go up here, this little button, and then over here, and then select the name attribute. You can select by name attribute, and you can roll over a piece that has the wrong color. So for me, this should be white and not black. And it is piece 487. So I'm going to go over here into our scene, find piece 487. Let's see if I can, in this crazy file. Okay, I'm very close. It's actually up here. Okay, right here. So if we go here, we can see that on piece 487, it's supposed to be material MB199. Okay, we're gonna go over here to the materials, MB199. Okay, so MB199, it is this like dark blue color, but it's supposed to be white, I believe. So now if I just back out into my X-Wing, it's gonna go ahead and recompile, and we can see if the pieces are the correct color now. And yes, they are. They look like they are the correct color, so that worked perfectly. One thing that you might want to do, and this is completely optional, but you can see like if you have any glass pieces that are supposed to be transparent, you might want to label them as such so that you can like correctly material them later on and they're not just a color. So I'm going to put down a prim wrangle, and this is completely optional here. But I'm just going to edit the name attribute for this specific piece. So to do that, I'm going to go ahead and select by name attribute, select my transparent pieces, hit enter, and it's just going to run over that specific piece. Then I'm going to edit the name attribute here, and I'm just going to say that it should be equal to the current name plus, let's say glass. And this is just going to give me like a unique identifier for it so that I can, you know, split it out later on and give it the correct material. And I'm going to call this like make glass. Okay. But after that, you really want to cache this geometry out. Like, you do not want to reopen this file and have to like go through this entire for loop again, because that's going to make you wait forever, especially if you have a much larger Lego set in your file, and I just don't want to wait for that. So make sure you put down a file cache node and call this ship cache or something. Explicit, it's not time dependent, so you don't need this frame number in there. And I'm just going to go ahead and save that. Okay, so now I don't have to run this loop again. But yeah, so we have our ship here. The next thing we want to do is actually like get this down to scale, because this Lego set is currently what, like 125, what is it, 250 meters across, something insane like that. That's way too large. So we're gonna do a match size node, and we're gonna hit scale to fit, and then we can hit F, and now, okay, yeah, this is our normal Houdini viewport. You can see 1 meter all around. Very cool. This is our X-Wing, but this is still, I think this might still be a little bit too big. So the way I kind of like scale it to be person size, or to be able to fit with a person, is I put the Tommy test geometry in my scene, which is like the size of a person, and you can like template him here so that you can see his wireframe. And yeah, this Lego set, I mean, a Lego set like this would be way smaller than this is. So I'm going to put down a transform node, and firstly I'm going to orient it, so I'm going to rotate it 90 degrees, and then I'm just going to scale it down until it looks like, oh, maybe that could fit inside of his hand. So around a 0.6. All right, that looks way more believable. Turn off Tommy here. Thank you very much for your service, Tommy. And then we have our tiny little X-Wing here. We're going to start getting it ready for our simulation. So we're just going to be cleaning up, optimizing this model. First thing I'm going to do is drop down a clean node and turn off remove degenerate primitives, because these Lego sets just don't seem to like that, but it is going to remove some unused points, and that's already going to bring us down a little bit. Not much. Actually didn't bring us down any for this particular Lego set, but it might help you in your specific case. But next thing we want to do is put down a fuse node. And this fuse node is just going to fuse points together, and you can see there's some wonky stuff going on here. We need this fuse node to respect our pieces, but this is operating on points, right? And the only way that our Houdini can tell our pieces apart is its name attribute, which right now is a primitive attribute. So we're going to put down an attribute promote And in this case, it's going to kind of demote our attribute. But we want to demote our name attribute down to the point level. And I'm going to turn off delete original. And then in Fuse, I'm just going to turn on match attribute. And you can't really see a difference right now, but if we hover over these nodes, it had 617,000 points, and now it has 248,000. So that has reduced our point count greatly. So fantastic. Before moving on though, we do want to delete that like phony name attribute. So I'm just going to attribute delete that name attribute, because that's going to mess us up with our RBD workflow. So we should only have our primitive one now. Okay, perfect. So at this point, I think I'm going to poly reduce our model, and this is completely optional, but I think this is just going to kind of like optimize my model a little bit. And I'm gonna, I mean, you can see, so the studs right now, they have okay topology, but as soon as I do this, I mean, it's not gonna have better topology, it's gonna have crappier topology, but I mean, they're more low res, and this brought us down from 248 down to 125, so 50% of the original. And that was point count, sorry, but primitive count is half, right? Okay, perfect. And now a good practice would be to kind of like just make sure that your name attributes are working. So we're gonna put down a RBD exploded view node and plug it in. And here we go. Okay, this is just going to kind of offset all of our pieces and explode them out in space so we can see each of our pieces, and there's no points pulling on each other. These are just full Lego bricks inside of Houdini. Kind of orbit around here for a second. Gander at the beauty that is your Lego X-Wing inside of your digital software, which maybe seems a little bit sad, but we'll blow it up and make you feel all better. Okay, so we're going to put down a null. And this is going to be our high-res geo. I say that in quotation marks, I guess, because we just poly reduced it, but like this is going to be the geometry that we're not messing with. And if you wanted to maybe create convex holes or something, then don't do it to the high-res. But right now, we're going to start with our RBD workflow. So hopefully you're already familiar with this. If not, I'm sorry. I'm gonna breeze through it, but hopefully you'll be able to see everything, so you should be able to follow along if you so wish. So we're gonna do an RBD constraints from rules node here, and this is just going to create a ton of glue constraints for us, which will tell our set, where should it stay together and where it should break apart, when it should hold together under a certain amount of force. But we're going to create these constraints, and instead of center of mass constraints, we want surface points. This is going to be a lot more, and this is very heavy, so let's do 2 connections per piece, or I'm sorry, I'm actually going to do, let's do 2 constraints per piece. I'm going to turn max connections to 2, search points down to 50, and then search radius. We want to make sure that our pieces are only being connected to pieces that they are touching. So we don't want any of this nonsense down here. So I'm going to turn this down to 0.02 maybe. And that seemed to do the trick pretty good. Maybe 0.01. Yeah, that's pretty much perfect. That's great. Okay, so there we go. So we have an RBD constraints from rules. And then let's do an RBD constraint properties node. And this is going to give our constraints some strength, and it's going to make them glue constraints. So I'm going to turn the strength down to 10. And I want whenever there's an impact on our object, I want that impact to kind of like, the force of that impact to kind of ripple across the surface or through these constraints. So I'm going to turn the propagation iterations up to like 7 or 8. And then I'm going to do an RBD configure node. This is going to give our pieces real world properties here, and it's going to pack them for us. So in real life, Legos are made of this stuff called ABS plastic, which has a density of 1 gram per cubic centimeter. And translated to our user density here, which is in kilograms over cubic meters, that is 1,000. So this checks out already. And then everything else we should be able to leave that alone for now. And at this point in time, we're going to RBD pack our pieces up. But instead of plugging all of these little nubs or inputs and outputs into each other, I'm going to plug our high-res pieces into that first part, our constraints into the pink one, and then our proxy, or I'm sorry, and then our high-res coming out of this configure node into the proxy of the pack node. Okay, then I'm going to put down a transform node, and at this point you want to transform your model to be like at its initial starting point inside of your simulation. So I'm going to bump it up way up here, and over here kind of make it like angled down, kind of have it fly at the ground like so, a bit higher. Okay, perfect. Then I'm going to unpack it, and I'm actually going to take this null away and plug the high res into that. Cool. Then we're going to do our we're going to give our ship some velocity. So I'm going to do an attribute adjust vector node here and just plug our proxy into it. And we can select it. And we want to just give our ship some velocity. So I'm going to say negative. I want it to fly down a little bit and maybe go, was that forward in Z space? If you turn your velocity visualizers on here, you can't see anything because the packed pieces get in the way. So the way you can see that is put down an add node. We can connect it, say delete geometry but keep points, and there are your vector trails. So we can see the direction that the velocity is pointing, and that is the negative direction of these vector trails. So these are pointing away from the direction of our velocity. So we can edit this a little bit, have it kind of be more slick and sleek, and have it fly at the ground, like so. And the other thing that I would like to add is add an attribute, just vector, another one. And I'm going to give it some angular velocity. And angular velocity is stored in the W attribute. Let's do it some on the Z. Just have it spin a little bit. Perfect. All right. So at this point in time, let's do our actual simulation. So let's throw down a DOPNet. Everyone loves a DOPNet. Plug the proxy geo into the first input and the constraints into the second. There we go. Dive inside, and this is going to be a very simple, straightforward setup here. Just do a bridge of body solver and an RBD packed object. Sorry about that. Plug that into the solver, plug the solver into the output, and then of course let's get some gravity going in here. Plug that in right here, and let's get a ground plane and a merge node, and we're just going to merge this in. And I like to turn off my ground plane, I don't like to see it. And then we need to bring in our constraints. So let's do a constraint net. Constraint, I typed that in wrong. Constraint network. There we go. Plug that in there, and then do a glue constraint relationship. We're going to plug that into the green input there. Okay, so on the glue, so first thing we're going to set up is this glue. I want the multipliers to all be 1 because we've already set up these properties. The name of our data is just glue. On the network itself, we're going to turn this off and say that our constraints are coming in the second context geometry. And then for our geo, it is first context geometry. And we're going to say inherit velocity. All right, so we got our geometry and the constraints all set up. One thing that you want to be mindful of is because our scene is so small, the bullet data may not be completely correct. So I'm going to turn off display geometry, turn on show guide geometry. You kind of see this is our simulation geometry here, which is a little bit too big. So I'm going to scroll down and just turn like collision padding down to like 0.0075 or something. And that's a little bit more accurate to what our geometry is. Turn this off, display geometry. Okay. So with all of that being said, I think we're finally ready to simulate. One thing I would say is add maybe a couple more sub-steps here. I would do 3, but I'm just gonna do 2 for the sake of this tutorial, for the sake of time. And then I'm going to just merge in the RBD stuff. Okay, so let's go ahead and see what this looks like. So first sim. Oh, okay, that was pretty cool. It just kind of falls straight down, it looks like. I mean, that's cool. We see the ship pieces all kind of come apart here, but that's maybe not really what we would like. I think I want a little bit more velocity here, so let's turn that up and then reset it. There we go. We got a little bit more launch to it. Might even be a little bit too much. I don't want this much downward motion, I don't think. Let's try that. Very cool. Okay, so this is working great. I would just say with our constraints here, and honestly, also when you're simulating, you want to be coming back to this node. I like to highlight it with like a different color, make it pink. But yeah, I'm going to turn the strength of our pieces down a little bit so we have more of them are falling apart. Yeah. That's so cool. Okay, yeah, so now we have our ship. It's kind of spinning in for this crash landing. It hits, it blows up. Oh no, there's all the pieces. And okay. Anyways, yeah, so we have this middle piece here that is still intact. It looks like it didn't absorb much of the impact, but the rest is scattered along the ground. Whatever. Yeah, I mean, this is pretty much it. This is the simulation part. One more thing I'll show you is the actual, I guess, importing it back into your scene. So we're going to do a little, DOP import here. And we want to import this .net. Object should be RBD. I'm going to say create points to represent the object. So you can see we have our points now. Then I'm going to do a transform pieces SOP. And I'm going to plug my high-res geo into that first part and our DOP import into that second part. And also it might help to do like a time shift here, shifted to the start frame of your simulation, which in this case should be 1 if you didn't change anything. Just plug that into the rest points. Okay, there we go. So now we have our high res geo being transformed, being shattered all over the ground. There we go. It's perfect. If you wanted to, you could do maybe like a time blend node. And let's see, maybe drop that down here. And then in here I want to do by speed, and I like to just copy these parameters down into here. And then we can do like, so it's going to come in right here and then keyframe. Actually, you know what? I might actually just keyframe 1 frame before and then go a couple frames forward. Drop this down to like 0.1. Let it play, let it play, let it play, let it play. And then here, back to 1. And this is, you can see these pieces are kind of like rotating sporadically here, which is not good. What you want to do is hit interpolate rotation of normals in all of this. And you also want to copy the amount of substeps that you're doing into here. That'll give you more data to work with if you're doing more than one. And now, yeah, look at that. That is so cool. It's so sick. Bam, bam. Yeah, now it's simulating, but very cool stuff here. And of course, you can do your own little rendering setup and lights and all that stuff, but that is really the gist of it. Other than that, just have fun and destroy all the Lego sets you want and make something cool. And if you do, tag me on Twitter or Instagram. My accounts are DaytonFX. I'd love to see if you make anything. If you enjoyed this tutorial, like it and please subscribe to my channel. I haven't posted anything in a very long time, but I've learned Houdini since, and I'd love to make more tutorials on this kind of thing. So let me know if you liked it in the comments below, and I will see you next time.